discrete time Fourier transform. Discrete time Fourier transform. DTFT. DTFT. DTFT applicable for xn x omega converted into frequency domain. DTFT. It is subpart of Z transform. Z transform. Because in Z transform we are putting this value if R is 1. DTFT calculated at unit radius circle. Unit radius circle as we discuss in Z transform. For DTFT we use formula summation minus infinite to infinite xn e power minus j omega n xn 1 upon 2 pi x omega e power j omega n d omega. In this expression we find DTFT. It is inverse DTFT. DTFT IDTFT inverse DTFT. In inverse DTFT, this is a continuous type of signal. xn is discrete sequence. It is continuous type of signal. DTFT have two component. One is magnitude spectra and second one is phase spectra. Magnitude spectra and second one is phase spectra. Phase spectra, and in this case if xn is real then mod of x omega is even function of omega distal frequency, and phi omega is odd function of omega. And for convergence issue this signal should be converged. Convergent issue is as per Z, no difference. This can be achieved through Z transform if Z is replaced with e power j omega. R j omega means complete magnitude and phase separation. If R is 1 means Z is calculated at unit circle, means it converted into DTFT. For example, we take a question. I take a question. In this question, if we first calculate Z transform, we easily calculate the Z transform. This, as per Z transform, ROC of Z is greater than A. A is less than 1 means Z is greater than this. Our system is stable. This condition is fulfilled. Now move to second part of this question. We want to calculate DTFT. DTFT. First we calculate Z, which is shown as Z upon Z minus A. ROC is this one. So by putting new value of Z, 1 upon 1 minus AZ inverse, by putting Z equals to e power omega, we got DTFT. DTFT is 1 minus A e power minus j omega. It is DTFT. We can further solve through Euler formula, cos theta plus j sin theta. It is formula given by Euler. We can use this here. 1 minus A cos omega minus j even plus j A sin omega. We can calculate magnitude portion, and this is the DTFT. We can calculate magnitude portion and phase portion separately. The magnitude portion is magnitude spectra. We can write in this way: real portion square and imaginary portion square and root of this. And angle portion come out in this way: division of these two. Tan inverse imaginary portion and with negative sign imaginary portion and real portion, a sin omega 1 minus a cos omega. We can calculate real and imaginary portion. We can draw also with the simple value of, by putting value of a half, maybe 1 by 3, and so on. We took one more question from discrete finite sequence, uh, which is the question of gate. This question in gate 10, 2 at location 1, value is 3 by 2. At location minus 1, again 3 by 2. Location 2, value is 1. And location 3, half. We have formula to calculate DTFT is minus this to this xn z power minus n. By putting value of z, formula is now converted into DTFT. DTFT always related to z. First write formula for z and then put the value. This all the samples are in within 3 to 3, means remaining are not our concerned portion, means we directly reduce the formula in this way. In this way. Then we put the different values. Half, first we put minus 3, half e power minus j omega minus 3 plus, put half plus 3 e power minus omega and 3 plus 1. Now location 2, e power minus 2 e power minus omega 2, and last 3 by 2 e power j omega minus 1 or minus j omega plus at 0 location 2. We assemble all the values and final result come to us is in this way: cos 3 omega 3 omega and 2 cos 2 omega plus 3 cos omega plus 2. This question in the gate question paper in the link category, two questions are coupled. They in the second part of the question they shift this sequence by some amount, n by 2 minus 1 yn. Given diagram for xn, calculate y. Now then complete expression is in between 3 to 3 we have to shift between these. Modification for yn will be complete expression solve for n minus 2 and 4 minus 4 and 8. This complete expression is now newly defined range in this range, and we can draw yn, and after that we can develop DTFT for that. The yn may be drawn as we got yn in this way, spread in this way, and we can calculate DTFT for that. Yn equals to directly writing expression for that and conclude into the sample. I write expression in terms of samples. Now we will write in the sample format and then apply DTFT formula y omega. Then we will just find the result by applying DTFT formula 8 yn e power minus j omega half e power and also minus j omega minus 4 plus 1 e power minus j omega minus 2 plus 3 by 2 e power minus j omega into 0 plus 2 e power minus j omega 2 plus 3 by e power minus j omega 4 plus 1 e power minus j omega 6, and last 1 by 2 e power minus j omega 8. We can arrange in cos pattern and final answer will be arranged in cos term, cos omega term. Now we will discuss I am discussed discrete Fourier, which is not important in electrical, only in electronics. Discrete Fourier transform DFT. DFT is basically discretizing in frequency of DTFT is result of DFT. Therefore in DFT both time and frequency are in discrete format. Means DFT comes from discrete sequence to discrete pattern. Both are in discrete time domain as well as frequency domain. We are just discretizing DTFT. DTFT is continuous pattern. we are just sampling this DTFT. So DTFT formula is which is which DTFT formula come from Z transform. So I start from Z transform, this, where Z is replaced by this term. If someone replace Z by this term, means it converted into DTFT, and DTFT formula become e power minus j omega n. If this term is discretizing, means k. How it is discretizing? Means this digital frequency is converted into 2 pi upon n into k. A discretizing of digital frequency 2 pi upon n into k. It is periodic. So by putting this value, we get from n to 0, n to capital N minus 1, where capital N is fundamental period. Capital N minus 1, total samples are n from 0 to n minus 1. In DFT, total samples are 0 to n minus 1. Xn e power minus j 2 pi upon n k small n. This is basic formula for DTFT. Sorry, DFT. It developed from DTFT. If we sample DTFT, means it converted into DFT. Sample the spectrum of DTFT is DFT. In short, we can say that sample the spectrum of DTFT is DFT. By sampling, we can get DFT. DFT has number of sample from n sample, which is from 0 to n minus 1, n point. In Z transform on unit circle at equidistance point 2 pi upon capital N is called DFT. One more definition: Z transform on unit circle means we reach up to DTFT and then circle at equidistance point 2 pi upon capital N is called as DFT. This is a small introduction of DFT. What is DFT? By sampling we can achieve.